The following is an Encore presentation of Everything Everywhere Daily.
Every single rocket that has ever been launched into space has been a rocket that burns some sort of fuel. These chemical fuel rockets have worked well for making the short trip to orbit. Beyond that point, however, they're not necessarily the best option for space travel. There are a host of proposed methods for space travel that don't involve chemical rockets, some of which have already been tested. Learn more about alternative forms of spaceflight and the possible future of space exploration on this episode of Everything Everywhere Daily. This episode is sponsored by Quince. It's summertime, and that means it's time to bring out the summer clothes. If you're looking to update your wardrobe this summer, I suggest you check out Quince. Quince has all the things you actually want to wear this summer, like organic cotton silk polos, European linen beach shorts, and comfortable pants that work for everything from hanging out in the backyard to nice dinners. And the best part? Everything with Quince is half the cost of similar brands. By working directly with top artisans and cutting out the middleman, Quince gives you luxury pieces without the markups. I recently needed a new duvet, and I went to Quince and picked up a great one that looked much better than what I had before, and all at a fraction of the price I'd pay elsewhere. Stick to the staples that last with elevated essentials from Quince. Go to quince.com/daily for free shipping on your order and 365-day returns. That's QUINCE.com/daily to get free shipping and 365-day returns. Quince.com/daily. This episode is sponsored by Planet Money. Tariffs, meme coins, Girl Scout cookies, what do they all have in common? Money. Economics is everywhere and everything fueling our lives, even when we least expect it. If you're a fan of Everything Everywhere Daily and are curious to learn something new and exciting about economics every week, I recommend you listen to the Planet Money podcast from NPR. What I like about Planet Money is that I can get an update on the week's financial news in about 30 minutes. Stories like the adoption of stablecoins or the price of eggs. From the job market to the stock market to prices at the supermarket, Planet Money is here to help explain it all. The Planet Money hosts go to great lengths to help explain the economy. They've done things like shot a satellite into space, started a record label, made a comic book, and shorted the entire stock market. All to help you better understand the world around you. Tune into Planet Money every week for entertaining stories and insights about how money shapes our world. Stories that can't be found anywhere else. Listen now to Planet Money from NPR. If you remember back, I previously did an episode on the rocket equation. The rocket equation involves the difficulty of rockets and fuel. If you want to put 100 kilograms of something into orbit, you need a whole lot more than 100 kilograms of fuel and rocket to get your payload into orbit. The bigger the rocket gets, the bigger the problem becomes. Because the bigger the rocket, the more fuel you need, and that fuel needs fuel to lift off, and so on and so on. Almost everything I talked about in the rocket equation episode dealt with just getting into orbit. This episode is all about how you travel once you get to space. The problems with the rocket equation and fuel still apply when you get to space, and if anything, the problem actually gets bigger. All of the space probes that we've sent to the outer solar system weren't sent there totally by rocket power. They were sent to nearby planets where they were catapulted using the force of gravity. The gravitational assist worked because of the alignment of the planets and because it was a one-way trip. If we just tried to use chemical rocket power to get to the outer planets, most of the probes still wouldn't have arrived because they'd be traveling so slowly. Chemical rockets can work for short distances, like maneuvering in orbit or flying to the moon or maybe even Mars, but they're not ideal. So, in this episode, I want to go through the various ideas that have been proposed for how to travel in space without using chemical rockets. The first type of propulsion is called ion propulsion, or more generally, electric propulsion. If you remember back to my episode on the rocket equation, I mentioned that rockets work by tossing hot, fast-moving gas out their back end. It would be like being in a boat with a pile of rocks and then tossing the rocks backwards to make the boat move forward. It's due to Newton's laws of motion that says every action has an equal and opposite reaction. An ion drive works similar to a regular rocket engine, except that there's no chemical reaction. Ion thrusters operate by using electricity to ionize a propellant, typically a noble gas like xenon, creating positively charged ions. Xenon is an ideal fuel because it's a very heavy gas, and the heavier the gas that's expelled, the more momentum the spacecraft will get. These ions are then accelerated by an electric field generated within the thruster, and they're ejected from the spacecraft at high speeds. Ion thrusters produce much lower thrust compared to conventional chemical rockets, and their high exhaust velocity allows them to be far more efficient, gradually enabling a spacecraft to build up high speeds over long durations. This makes ion thrusters particularly suitable for long-duration missions in space, where they can slowly but steadily accelerate spacecraft to high velocities. There are several things that make ion thrusters attractive. In addition to their efficiency, they don't require oxygen or any fuel that can combust. You just need one single fuel that doesn't have to react with anything. The electricity to eject the ions can be created from solar panels, which can create power indefinitely so long as you are a reasonable distance from the sun. Ion thrusters and other types of electronic propulsion are commonly used on satellites today for altitude control. If their orbit is decaying, they can be sent to a higher orbit, and if there's a risk of collision with something, they can just move. Ion thrusters don't provide enough thrust to lift something from the surface of the Earth into orbit, but they're great when you just need to nudge something that's already in space. But what if you need something a bit more than a nudge? What if you want the power that comes from a chemical rocket reaction, but you don't want to use a chemical rocket? Well, one solution would be a nuclear thermal rocket. In a previous episode, I talked about Project Orion, a plan to use literal atomic bombs as a form of propulsion. That was a harebrained and horrible idea. A nuclear thermal rocket is nothing like that at all. A nuclear rocket uses nuclear fuel, very similar to that used inside of a nuclear reactor. The rocket engine would consist of a nuclear core that would undergo a controlled nuclear fission reaction, making it extremely hot. A gas would then be heated by the nuclear core, which would cause it to expand and be expelled just like it would be in a chemical rocket. The physics behind a nuclear rocket is actually pretty straightforward. The idea of using nuclear fuel for space propulsion actually dates back to the 1940s. In 1961, the United States formed the Space Nuclear Propulsion Office, which was a joint effort between NASA and the Atomic Energy Commission. They developed a nuclear rocket engine known as NERVA, which stood for Nuclear Engine for Rocket Vehicle Application. Between 1962 and 1969, they conducted 48 tests of 6 different NERVA engine designs. Each of the designs was capable of producing over 1,100 megawatts of power. During its longest test, it was able to operate at full power for an entire hour. So this isn't some theoretical pie-in-the-sky technology. Depending on the design, and there are several different ones, nuclear propulsion can be 3 to 5 times more efficient than chemical rockets. NASA and DARPA, the Defense Advanced Research Projects Agency, have announced that they're currently working on a nuclear-powered rocket called DRACO, which stands for Demonstration Rocket for Agile Cislunar Operations. DRACO is currently scheduled to be tested in space sometime in 2027. Nuclear propulsion is the only realistic option for travel within the solar system currently. A chemical rocket would take 8 months to travel from the Earth to Mars. A nuclear rocket could make the trip in just 45 days. Moreover, it would only require carrying lightweight hydrogen and no oxygen. While hydrogen would be the best fuel, and it is the most abundant element in the universe, other gases could be used as well, which can be harvested on other planets or moons in the solar system. The current efforts in nuclear propulsion are the most serious that have been undertaken, and even companies like SpaceX are currently investigating nuclear propulsion as well. While nuclear thermal propulsion might be a good, realistic technology for exploring the solar system, what about if we wanted to travel further? Here we have to get into more theoretical forms of travel. All the systems I've just mentioned do require some form of fuel to be expelled. But what if you didn't need any fuel at all? Instead of expelling matter via a nozzle, could it be possible to just push a spacecraft externally? Well, the answer is yes. And it's called a solar sail. And it works on the principle that light can exert a very weak amount of pressure. Despite having no mass, photons do in fact have momentum. And this actually takes many people by surprise because the definition of momentum is literally mass times velocity. However, the equation only holds at Newtonian levels that we deal with on a daily basis. At the relativistic speeds that light travels at, it does have momentum. To capture the very weak pressure of light, you need a very large sail, potentially many square kilometers in area. Moreover, the sail would have to be extremely thin and lightweight. The benefit of a solar sail is that while pressure from light is small, it's constant. Once you unfurl a solar sail, the pressure from the sun would constantly accelerate the ship, which over time would seriously add up. In 2010, the Japan Aerospace Exploration Agency launched and deployed Icaros, which was the first true interplanetary solar sail. It only had an acceleration of 1 millimeter per second squared, which isn't much, but it was constant. Likewise, NASA and the Planetary Society have both deployed test small-scale solar sails. A solar sail is often thought to be the preferred method for sending a probe to a nearby star. You deploy a large solar sail, point it at a star like Proxima Centauri, the closest star to our Sun, and let the Sun accelerate it until it leaves the solar system. It could theoretically reach speeds up to 0.1% the speed of light. Then, as it approaches the other star, the process would work in reverse. The light from that star would push the other way, slowing the solar sail down. But what if you wanted to go even faster? One option that has been floated would be propelling a solar sail with powerful lasers on the Earth or the Moon. Once again, the science behind solar sails is pretty well established, and there have been tests run, so this isn't something that's in the realm of science fiction. It's a real technology that just hasn't been deployed on a wide scale. Even if a solar sail traveled at 1/1000th the speed of light, it would still take a long time to get to another star. So, is there anything even better that is possible? One idea is to collect fuel as you go. In 1960, physicist Robert Bussard proposed an interstellar ramjet. And the idea here is pretty simple. Space is not a perfect vacuum. Even in interstellar space, there are random hydrogen atoms floating around. The nose of the ramjet would be a gigantic funnel that would scoop up all of the stray hydrogen atoms and gas molecules as the ship was flying. In Bussard's initial proposal, the hydrogen would literally be compressed until fusion occurs, but that's now considered to be impossible. Nonetheless, it would be a way to get fuel during a long interstellar flight. If you collect enough gas, then it could provide an enormous amount of acceleration, even for a nuclear-powered spacecraft. I'm not even going to get into proposals for such things as fusion engines or antimatter propulsion because those things are all still in the realm of science fiction at this point. We have to figure out how to harness fusion or create antimatter before we can start thinking of applications for it in spaceflight. That being said, all of the other methods of propulsion that I've mentioned in this episode are very much real technologies that have either been deployed like ion thrusters or are in the testing stages already. And these new methods of propulsion will be necessary if humanity ever hopes to explore the solar system beyond Earth's orbit. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Austin Oakton and Cameron Kiefer. I want to thank everyone who supports the show over on Patreon. Your support helps make this podcast possible. I'd also like to thank all the members of the Everything Everywhere community who are active on the Facebook group and the Discord server. If you'd like to join in the discussion, there are links to both in the show notes. And as always, if you leave a review or send me a boostagram, you too can have it read on the show.